One interesting demo that I pulled out from YouTube, it's put together by a teacher and students in a high school in Portland. It deals with what's called the Rubens tube. The principle behind this is to have a metal tube. Essentially, here we cannot see it in this picture right now, but we will see it operate, so it extends from here to here. One end of this metal tube is going to be closed. That's this end. At the other end, we have a small speaker that is fit to that opening. So we have a speaker at this end. The speaker is connected to a function generator, a device that's going to provide an electrical signal at specific frequencies. So we can have single tones that are going to be fed into the tube. Now, inside the tube, we put a flammable gas, something like natural gas or propane. At the top of the tube, we have equidistant holes, an array of holes that are equidistant. So with the flammable gas inside, when we light it up, we are going to get a flame. If there was no sound, barring imperfections in the holes, you are going to have a flame throughout here with an equal amplitude or equal height. Because of the sound, whenever we have a standing wave here, the standing wave is going to have areas of high pressure that are going to be represented by an antinode that we'll see in the flames, and low pressure that's going to look like a node, like what we see here. So antinodes and nodes. And that's what we will see. I'm going to run this demo. Okay, let's run this video.
I'm not joking.
Okay, you notice here we have antinodes, high amplitude, nodes here, antinodes. Look at this end here, that the closed end. We have an antinode, like we expect. Closed ends for pipes is going to be an anti-pressure node. The gas molecules are going to have a displacement node. If the flame was represented displacement, we'll have a node here. But the flame is going to represent pressure, and that's why we see an antinode here. Notice here, when we don't have a standing wave pattern, the flame is essentially uniform.
There you go.
Okay, you notice here, for a higher frequency, we have many more segments. So each segment, remember, is going to correspond to half a wavelength. We are not seeing the part here that has the antinode. The video is not perfect, but you get the idea.